Hello everyone. In this concluding video of theory of games, we are going to cover graphical method, then algebraic method. We'll just have an outline of this method, and then equivalent linear programming problems of a game. The graphical method, as the name suggests, is applicable for those games for which the pair of matrix is either m cross 2 or 2 cross n. That is, the games for which the pair of matrix is having either 2 rows or 2 columns. Now we will illustrate this method using some examples over here. To begin with, let's have an example of a game of the size 2 cross 3 with entries 2, 7, 3, 5, 11, 2. Now let's solve this game using graphical method. We have here player P1, P2. This is number 1 here. This is number 2 here. This is number 1 for P2 in the spheres, and number 3 over here. And in this game we are not supposed to find max, min and min max, as graphical method is to be applied over here. So straight away, because the number of rows over here is 2, so we start with the player P1. The player P1 will play first. So let P1 plays number 1. With frequency x, and number 2 with frequency 1 minus x. Then the expectation of P1 if P2 plays number 1 will be given by if P2 plays number 1 is, let me write this as y equal to, look at that, if P2 plays number 1, so the frequency over here is x and 1 minus x for P1, so the expectation will be 2 into x plus 7 into 1 minus x. Let's simplify this. This turns out to be equal to 7 minus 5x. Let's call this equation as number 1. Now similarly, the expectation of P1 if P2 plays number 2 is, it will be 3x plus 5 into 1 minus x, which is equal to 5 minus 2x. Let's call this as number 2 here. And likewise, the expectation of P1 when P2 plays number 3 will be given as 11x plus 2 into 1 minus x. This is which is equal to 2 plus 9x. Let's call it 3 here. Now since x, the frequency lies between 0 and 1, so we'll draw these lines, draw these 3 lines 1, 2 and 3 on x y plane for x in 0, 1. So draw the 3 lines 1, 2 and 3 for x in 0, 1, because the frequency lies between 0, 1. Next graph will be given by, the lines are y is equal to 7 minus 5x. Now 2 points on this line will be given by like this. You take x equal to 0, x is 0, then y will be equal to 7. So first point will be over here on the first line, and then you take x equal to 1, y will be equal to 2. So the point will be over here, 2. So just join these, you will get this as the first line. And then On the second line, we have when x is equal to 0, y will be 5. So this is the point here. And when x is 1, y is equal to 3. It's here. Then just joining these two to get like this one. And then the third one is when x is 0, y is 2. When x is 1, y is 11. So it's somewhere here. Just join this one. So this is the third line here. This was the first line and this was the second line here. Now, for each x in 0, 1, suppose I take this as the x over here. P1 is sure to get this sum or this sum or this sum. So it will be either this sum, this amount, or it will be from here to here, this amount, or it will be here. It means that for this x, he is sure to get the minimum of the 3 ordinates over here. This is the first ordinate, this is the second, this is the third one. Likewise, for this x, he is sure to get the minimum of the third ordinates, 3 ordinates. Likewise over here, likewise over here. So for each x in 0, 1, P1 is sure to get the minimum of the 3 ordinates. And the 3 ordinates are here, these are shaded ones. Remember that x lies between 0 and 1. Let's call it A, call it B over here. So now, since P1 would like to maximize his earnings, so he would like to go for the one for which these minima has a maximum. That is a point of max min over here. And the max min point is A. So from the graph, the max min point or the optimal point is A. And its coordinates can be obtained by solving the equation 3 and 2 here. 2 here. Now solving 3, we get, just solve this one and this one, we get here that x is equal to 3 by 11 and y is equal to 49 by 11. So the maximum point will be 3 by 11 and 49 by 11. Now this means that the best value for x is 3 by 11 and this is the expectation, the best value of the expectation is 49 by 11. Hence, an optimal strategy for P1 is 3 by 11, this is x, and then 1 minus x is 8 by 11. 1 minus 3 by 11 will be 8 by 11, and b equal to 49 by 11 is the value of the b. So using this graphical method, we obtain that optimal strategy for P1 is 3 by 11, 8 by 11 and b equal to 49 by 11 and as the value of the gain. Further, to find the optimal strategy for player P2, what we observe is the max min point A is the point of intersection of 3 and 2 here. So, an optimal strategy for the player P2 can be obtained using the point max min over here. Look at this max min. The point max min is the intersection of line 2 and 3. And so, an optimal strategy for P2 can be obtained by solving the game with second and third as the columns of this payoff matrix. Now, using our previous method, here, what is A minus B plus minus C plus D, that is delta, is equal to 3 minus 11 minus 5 plus 2, which is equal to minus 9 here. And so, an optimal strategy for P2 is is d minus b, that is 2 minus 11 divided by, sorry, this is minus 11, 2 minus 11 divided by this delta, that is minus 11, and 3 minus 5 divided by minus 11, that is 9 by 11 and 2 by 11, and v equal to, although it will be same as the previous one, 49 by 11, but also can be obtained from AD minus BC divided by this del here. This is del is A minus B minus C plus D, which is equal to AD minus BC. 3 into 2, 6, 6 minus 55, that is divided by minus 11 is equal to minus 49 by minus 11, which is 49 by 11. Hence, an optimal statistic for P2 is this one, with same as the value of the game. Thus, for the given game, an optimal statistic for P1 is 3 by 11, 8 by 11. An optimal statistic for P2 is, remember that he is going to play number 1 with frequency 0. So it's 0, 9 by 11, 2 by 11, and V equal to 49 by 11 as the value of the game. Solve the game having 2 rows. Now let's solve another game having 2 columns over here. Now look at this pair of matrix. It's minus 1, 0, 0, 4, minus 4, 3, and 2 minus 5. Since the game has 2 columns only, so we'll start with the P2, the player P2. Yes, I guess. Let P1, P2 plays number 1 with frequency Y, and number 2 with frequency 1 minus Y. Then the expectation of now all the time we will have the expectation of P1 because P2 is going to P2 P1. The expectation of P1, if P1 plays number 1, is x equal to, look at that, if P1 plays number 1, then the expectation will be minus y plus 0 into 1 minus y. That is, x is equal to minus y. Just call it 1. The expectation of P1, if P1 plays number 2, is x equal to 0 y plus 4 into 1 minus 5. That is, x is equal to 4 minus 4y. Let's call it 2. Likewise, if P2 plays number 3, the expectation of P1 plays number 3, then the expectation of P1 will be minus 4y plus 3 into 1 minus y. That is, x is equal to 3 minus 7y. Call it 3. Now likewise, the expectation of P1 when P1 plays number 4 will be x equal to 2y minus 5 into 1 minus y. That is, x is equal to minus 5 plus 7y. Call it number 4. Now we'll draw all these 4 lines 1, 2, 3 and 4 on xy plane for y in 0, 1. Being frequency, the value of y will lie between 0 and 1. Let's draw these 4 lines on xy plane for y in 0, 1. This is x-axis, y is equal to 0, this is y is equal to 1 over here. Okay, let's take the first line here. 2 points, one is at 0, 0, because you take y equal to 0, x will be 0. When y is equal to 1, y is 1 here, x will be equal to minus 1. So the point will be minus 1, 1. And let's join these two. So this is the first point over here. So this is the first line here. The second one is When y is 0, x is 4. So the first point will be here, and the second one is when y is 1, x will be 0. So this is our second line, and the line will be this one. The third one, when y is 0, x is 3, here it is, and when y is 1, x will be equal to minus 4. So minus 4 is somewhere here, is here. So this is that point. So up to 3 it will go. So this is the point here. And then we have the last one. When y is 0, x is minus 5. So this is that point over here. And when x is, when y is 1, x will be equal to 2 here. So this is 2 here. For y equal to 1, and this will be the line here. Now for each y in 0, 1. Say this is a y. In arbitrary y between 0 and 1, this is 0 and up to this is 1. P2 has to pay this sum, this sum, this sum, or this sum. So he has to pay at the most the maximum of the 4 FC side, and the maximum is here, this FC side. So he has to pay at most this one. And similarly for this x, he has to pay at most of maximum of 4 FC side. It's like this. For 0 it will be 4 units. For this onwards it will be like this, and so on. Is a shaded for each y in 0, 1. It will be like this. And he has to pay. Now since P2 would like to minimize his payoffs, the min-max point over here is this one. Let me call this as P here, is the min-max point. Or you can call it optimal point also for the player P2. Now this point being the intersection of, this is the second line, this was the fourth line, and this was the third one. So P is the point of intersection of second and fourth. Solving these two, this is second and this is fourth, you will get here just equating these two. 4 minus 4y is equal to minus 5 plus 7y. You will get 11y equal to 9. So y will be equal to 9 by 11. And then what will be x equal to? X will be equal to 4 minus 4y. That is 4 into 9 by 11. That is 44 minus 36 is 8 by 11. So the point P is 8 by 11, 9 by 11. Hence, an optimal strategy for P2 is y, that is 9 by 11, and 1 minus y, that is 2 by 11, and v equal to x equal to 8 by 11 is the value of the game. So graphical method gives up to this information, and thereafter as well an optimal strategy for P1. Now since 2 and 4 are involved in finding the point P, the min-max point, and therefore an optimal strategy for P1 can be obtained by solving the game with payoff matrix as this one. It involves the second row over here and the fourth row over here, which is 0, 4 and 2 minus 5. Now, using our previous study, we can find an optimal strategy for P1 like here. An optimal strategy for P1 can be obtained by solving the game with payoff matrix involving the row number 2 and row number 4, because the point P is the intersection of second and fourth. Now look, we will apply over here our previous method. Here it is, delta is A minus B minus C plus D, which is equal to A0 minus 4 minus 2 and plus d, that is minus 5, which is equal to minus 11 here. And then an optimal strategy for P1 is d minus c, that is minus 5 minus 2 divided by delta, that is minus 11, and a minus b, that is 0 minus 4 for P1 is minus 11, that is 7 by 11, 4 by 11 is an optimal strategy for P1, and the value of the game B will be AD minus BC, the determinant, that is 0 minus 2 into 4 is minus 8, and then divided by del is minus 11 is 8 by 11. Now thus for the given game, an optimal strategy for P1 is first number, the frequency will be 0, for the second number it's 7 by 11, for the third number it's 0, for the fourth number it will be 4 by 11. An optimal strategy for P2 is the same one, is 3 by 11, 8 by, no sorry, was 9 by 11 and 2 by 11, and V equal to X equal to 8 by 11 is the value of the game. Next, we are going to have some examples over here. Use graphical method to solve these games over here. The first one is 2 cross 3, next is 3 cross 2, and next is 4 cross 2. Each one of these games is having either 2 rows or 2 columns. So can be solved using graphical method. Now make sure that when solving a problem using graphical method, you are not supposed to find max, min and min max. Straight away you can start with the pairs P1 and P2 where they are with the frequencies, and then you are not supposed to even make use of the relations of dominance. Just straight away make use of graphical method as we described earlier. And finally, if a game is of 2 cross 2 matrix, then you can either start with the player P1 or you can start with the player P2. So the choice is yours. Now let's talk about algebraic method, which is a very useful and very strong method to solve any type of game. Now from our previous video, let's recall a little bit of that. Let EXY be the expectation function for an m cross n rectangular game. This is the expectation function of an m cross n rectangular game with pair of matrix AIG. We defined it in the previous video. Then what is EXY equal to? EXY is given by double summation AIJ XI YJ, where J varies from 1 to N, I varies from 1 to M, where X belongs to, what is this equal to? Is X1, X2, XM. It belongs to Sm. It is a set of all mixed strategies for P1. Y is equal to Y1, Y2, Yn in Sn, set of all mixed strategies for P2. So we have this EXY as the expectation function for an m cross n rectangular game with pair of matrix AIJ. We have by previous result that max min EXY and min max EXY both exist and are equal. Now this guarantees that the expectation function EXY has a saddle point, say x star y star. We call this as a strategic saddle point of the game. It's a strategic saddle point. Then precisely we'll have Ex y star is less than or equal to Ex star y star is less than or equal to Ex star y for all x's in Sn and for all y's in Sn. Then Ex star y star will be the value of the game. X star is an optimal strategy for P1, Y star will be an optimal strategy for P2. Consequently, one of the main results is that every rectangular game is solvable. Each player has an optimal strategy. So every rectangular game is solvable, has a value, and that comes from these results. Now before moving further, we'll try to define some particular types of mixed strategies for P1 as well as for P2. Let's define a pure strategy for P1. Nx equal to x1, x2, xn in Sn, that is a mixed strategy, is a pure strategy for P1 if xi is equal to 1 for some I in 1 to m and xi is equal to 0 for all other i's. It means that one of the components of this x in case is 1 and others are equal to 0, then such a mixed strategy is called a pure strategy. Now, we'll denote such a pure strategy by xi. Now, in fact, there are m pure strategies for P1, namely x1, 1 is the first component and others are equal to 0. In all, there will be m components over here. x2 equal to 0, 1, 0, 0, zeros, all others will be 0 except at that second place, and likewise xm 0, 0 and 1 in the end. Now on the same lines we can define pure strategy for P2, which is y in Sn with n components over here is a pure strategy if yj is equal to 1 for some j in j and yj is equal to 0 for all other j's. Now such a pure strategy likewise we define for P1 over here for P2 is denoted by yj. In fact, there are n pure strategies for P2, namely y1 equal to 1, 0, 0 and having n components. In y2 also there are n components where the second component is 1, others has 0, and yn 0, 0, the last nth component as 1 here. We have this notation over here for an m cross n rectangular game. Let exy be the expectation function of an m of the game. Then for x in Sm and y in Sm, we define eiy as exiy. It means that P1 is playing with xi, that's the pure strategy, I is pure strategy, whereas P2 plays with y, then this is denoted by this one, which is given by sigma aij yj, j varies from 1 to n for each I in I. And similarly, we define for each j in j, exj equal to exyj, which is equal to sigma aij xi, I varies from 1 to m. This means here that P1 is playing with x, whereas P2 plays with the pure strategy yj.